All right, we're going to look at reviewing of exponents and polynomial operations. This is 8-1. So the first thing we're going to learn about is what are the parts of a power. So this 3 right here is called the exponent. That should be review. All of this is a review, hopefully. So exponent. The 2 is called the base. Okay. The exponent, so I'm going to just put exp for exponent. The exponent tells us how many times the base is multiplied together. Okay, so remember this is like writing it 2 times 2 times 2. So 3 times. Okay, and then we could solve that and put that in our calculator if we wanted, or we can put it raised to the 3. Okay. If it is a constant or a variable does not have a written exponent. So it doesn't have anything, it's automatically an exponent of 1. So over here, if we have just the regular number 2, it has an exponent of 1. And if you put that in your calculator, this 2 exponent of 1, you'll also just get 2. Okay. Over here, we can add in a 1 here and a 1 here. All right. If we were to write it out, rewrite it, you could write it here and here. So y squared z has a 1. Okay. This is going to help us remember when we're just about to go and use it for operations. So remember, you may only use the following exponent rules with like bases. So we're going to get to an example in that in just a second. Let me scroll down a little. You can always pause, rewind, go back. So power to a power. This is when we have an exponent on the outside of our parentheses. Okay, so notice that, let me do it in yellow. This exponent here, this 3, is on the outside of our parentheses. All right, it's going to show that we're going to multiply. So if I were to do this problem, I'm going to have x 2 times 3. Okay, and my answer, 2 times 3, is 6. So exponents multiply. And that's only when they're on the outside of a parentheses. So you have to have the parentheses here in order for that to happen. Okay, so let's do another one. So if we scroll down a little. All right, so now it looks like they're multiplying. What happens to our exponents? Our exponents are going to actually add together. Okay, it looks like multiplication, but what's going to happen is it takes our 2 and our 3 and we'll add them together. And your answer would be x to the 5th power. Okay, so this one up here, we had our parentheses and the number was on the outside edge. Here we have our exponents adding. If we move down a little bit more. Okay, now it's showing us addition. All right, there's a plus sign in between 2 terms. These 2 terms, they have the same base, okay, but we have to treat them like terms. This term is different than this term. When we were combining like terms, if they had a different exponent, then we can't combine them. So that we just are going to leave that one just like it is. We can't do anything to them. Now here, this is an x squared and this is an x squared. We can combine them and we're going to get, this is 1x squared plus 1x squared, and you get 2x squared. Okay, so this one they can add together. It still stays an x squared though. Our exponents do not add. All right, so let's go back up here. All right, when dividing powers with like bases. So when dividing powers with like bases, treat the division bar like a giant subtraction sign. So you're going to write subtraction. Okay, subtraction. Or if you want to just do a giant minus, subtraction sign. It says there's a war between the top and bottom of the fraction. This is where our subtraction sign would be. The side with the most soldiers or variables wins and keeps the survivors. Let me scroll down a little. So here's an example. When we have x to the 9th power and is divided by x to the 3rd power, we're going to act like they will subtract. So x, and we have 9 minus 3. 9 minus 3 is 6. So there is our answer, x to the 6. Okay. If we do this one, this leads us into our next, what we're going to talk about. So if I have y, it's going to be 2 minus 5. We always go from the top of our fraction to the bottom. We always work our way down this way when we go to subtract, okay? So this one, if you are not familiar with doing your integers in your head, this gives you a -3. Use your calculator and subtract. Let me erase that real quick here. Okay, so we have y, and we have -3. So this is all good. We got the right answer, but we can't leave it as a negative. So the rules about negative exponents, and if you look down a little bit further at your paper, let me scooch this down so you can kind of see what happens. Negative exponents are traitors. We put them on the other side where they belong. All this means is it's going to flip the side. So we're going to make our fraction bar again. We're going to put a 1 here because there's nothing else, and the y comes to the bottom, and your exponent becomes positive. Okay? So flip. Okay, that means if it starts on the denominator, it would flip to the top, to the numerator. Okay, so we're going to flip to the other side. That's why it says it becomes a traitor. Okay, and then it becomes positive. Becomes positive exponent. Because we can't leave it as a negative exponent. So this right here would be my answer. Okay, in just a little bit, we're going to get to see some examples of doing this a little bit more. Okay, let me scoot it down just a tiny bit more for this next little bit. All right. And last, it says negative exponents right over here is where I'm at. Okay, remember we're going to flip to the other side. So this one has an x and a y. I cannot add or subtract. I can't subtract these two exponents because they're different bases. This has a base of an x here, and this one has a base of a y. Two separate things. I can, however, flip them upside down. Okay, so my y, let's start with the x. X is -2. So the opposite is to bring it down, and that 2 becomes positive. The y does the opposite. It goes up to the top, and it becomes positive. Okay, they flip to the whatever side they're not already on. Okay, on this one, they're both x's for the base, so we can subtract them. So we're going to say x, and we have 4 minus -2. Throw that in your calculator. X equals 6. So sometimes it even gives us a positive answer. All right. The very last thing that you learned about, anything raised to the 0 power is 1. So if we were to put this in our calculator, we would still get 1. You could do 7,342 to the 0 power, and it would still be 1. You can make the largest number possible as long as you put it to the 0 power. Okay, it is still 1. And if you wanted to test it out in your calculator, you're looking for the button that looks like a rooftop. Okay, it's kind of over there by clear, I believe. Not 100% positive, but I'm pretty sure it's over there by clear. All right, so let's look at some examples. So if you want to turn your page, and remember, go back, rewind if you need it. Okay, so here's a little bit of notes on polynomials. We did this before we went to winter break. Okay, adding like terms, make sure to distribute the negative when subtracting. So this is where I would underline or circle or box in like terms. I'm going to use probably different colors. You could use different colors. You could use 2 lines, whatever you want to do to show that these are all separate from each other. So if we're just adding, that means our exponents are going to stay the same. Okay, we're going to add our whole numbers. So like 3 plus 6 is 9. A -5 and a -2 make a -7ab. And then 4b minus 6b is -2b or -2b. And there's your answer. You can't do anything else. Over here, what they're saying is make sure to distribute the negative when subtracting. It just means that this is a -3. This is now going to be a -x, and this is now going to be a +1. Okay, it changes the signs. So I have x squared minus 3x squared. I get -2x squared. On this one, I get -5x plus x, so I get -4x. Or I get a 2 plus 1, because I've already distributed that subtraction sign, so I get +3. All right, so that's adding and subtracting polynomials. Quick review. Now, if we are going to multiply, let me scoot it down a little. Okay, we did all of this before break. Remember, with multiplying, this is distributive property. When you have numbers, right? This 3x squared is going to multiply times each one of these. Now, your exponents are going to be like what we learned just above. You're going to add your exponents. So if you need to write yourself a note, add exponents, EXP. And if you want to write the whole word, write the whole word. Okay, so 3 times 2 is 6. And then this has a 1, remember, and 1. If it doesn't have anything, it's a 1. So x becomes x third, because 3 plus 2 is 1. Or sorry, 2 plus 1 is 3. Where my thinking is. And then there's no y to add to, so the y just comes down. Minus 3 times 3 is 9. X again is going to add together. 2 plus 1 is 3. And then the y doesn't have anything to add together, so it just brings down the y squared. Plus 3 times 4 is 12. And there's nothing to add with the x squared, so the x squared comes down. Okay, so we multiplied our whole numbers. We added our exponents. Same thing here, but we're going to do it twice. So the n is going to multiply times each of these 3 terms. So let me do those first, and then we'll go back and catch the 9. So we have 4, and we have n to the 3rd power. And then plus 7n squared minus 1n. Okay, let me switch colors so you can kind of see what happens. This 9 is then going to multiply times each of these. We get -9. Oh, whoops. 9 times 4 is 36. So let me put a 36 and n squared. That's a 6. It's a horrible 6. I'll fix it in a minute. Minus 63 n, and then plus 9. Oh. All right, I'm trying to write 36 n squared again. 36 n squared. Kind of better, maybe not. Okay, so again, I'm going to combine like terms. So I'm going to combine my n squareds with n squareds. And I'm going to combine my n's with n's. And that's it. That's all I can combine together. So I have 4n cubed minus 29n squared. I'd throw that in my calculator and make sure you get -29. You have minus 64n plus 9. Okay, so that was a bunch to do. Okay. Let's look down at the next examples. You can always pause, rewind, go back. Okay, so these examples are going to be multiplying with exponents also. So remember, if we're going to multiply these out, this is a single term. This right here is a single term, and this is a single term, okay? So I have I have 2 times -4, so you get -8. Okay, your exponents will add on these. So what is 3 plus 2? and you get 5. And what is negative 2 plus 4? And you can throw that in your calculator if you don't like it. Negative 2 plus 4 is a 2. And we're done. That's it. Now, number 2 has a little bit more. We didn't talk about it, but if there's a number on the outside of our exponent, we're going to multiply exponents. However, there's a number here on the inside that we have to deal with, so it's really 6 to the third power. You do need to grab your calculator. If you don't know where the exponent up button, remember it looks like a rooftop house. That will help you get there so you can raise it to the third power. You get 216. Okay? Do not put 18. 6 times 3. No, it's 6 to the third power. So 216. And G, 5 times 3 is 15. H, 3 times a negative 4 is negative 12. Remember, we can't leave it like this as a negative. Okay? What I'm going to do is I'm going to take this negative 12 and I'm going to put it on the bottom of a fraction. So I have 216 G to the 15th, H to the 12th. And now I'm done. Okay. On this number 3, 12 divided by 2 is 6. 4 minus 1 is going to be 3, so x to the third. 2 minus 5 is to the negative third power. Okay, but remember, we can't leave it like this. We want to write it with a fraction. These are positive. 6 and x to the third power are positives. So these y to the third goes to the bottom, and it becomes positive. This is our answer. Okay, can't leave a negative. Okay. We're back to regular polynomials. I know it switches. This is going to make a negative 7a minus 4a squared is 3a squared. Remember, our exponents don't add on these. We have 6a, and it's really going to be plus a 2a because it distributes that sign. And you get nothing, right? This cannot add with this. Oh my goodness, it doesn't have an a. Don't add. This 7 can add with the 2. So we're just going to bring down our 6a. It's all by itself. But it's a negative 7 plus 2 is negative 5. So those two can add together. Okay, number 5 and 6 are a little bit longer because not only do we have to multiply, we have to add our exponents together. So let's look at number 5. I'm going to multiply the first term times all 3 of these terms. Okay, so 2 times 3 is 6. If I add my x's, I get x to the third power. 2 times 8 is 16. And my x's are going to add, so I get x squared with my y coming down. And then 2 times, this is a 1 in front of the y squared, so just 2x, and my y squared comes down. Okay, oh, that's not a great squared. Let me try and rewrite that. Not much better. Okay, this is all going to be completely added together. I just don't have room to write it on the same line. But we're going to multiply these negative 5y to each of the 3 terms. So, I'm going to just write down here. Minus 15y, or sorry, I'm going to do my x first because I did my x first up here. X squared y. It doesn't matter which way you write them, x or y first. It does not matter as long as you stay consistent. And then negative 5 times 8 is negative 40. And I have my x comes down, and I have y squared because my y's add together. Those exponents do. Negative 5 times 1 is negative 5, and my y squared plus 1y gives me 3. So y to the power 3. What can I add together? I can add this 16 x squared y squared with this x squared y. I can add the xy squared together with the xy squared. Okay, my answer. Oh my gosh, there's so much going on, isn't there? We have 6x cubed, and we have plus 1x squared y. Then we have minus 38xy squared, because I have a plus 2 up here and a minus 40 here. And then my last is just my ending, minus 5y cubed. There's nothing to add or subtract that with. This would be my answer in green. Okay. That was the longest one so far. Okay. Now, anytime we put something to a power, like number 6, okay, that means we're going to write it 3 times. So really I have c minus 2 times c minus 2 times c minus 2. Okay? This problem, you're going to separate. I'm going to do the first 2 terms, these 2 terms first, and I'm going to multiply them out like we've been doing distributive property style. C squared minus 2c minus 2c plus 4. I went ahead and came over here. Okay? If I combine that together, I get c squared minus 4c plus 4. Okay? Now I cannot forget about this last c minus 2. So I'm going to go here, and I'm going to put c minus 2 on the front of it, and we're going to multiply it out one more time. Okay? It's going to look a lot like number 5 did. So c times c squared is c cubed. C times minus 4c is minus 4c squared, because I add my exponents. 4 times c is 4c. Okay, now that part's done. I'm going to go in and multiply the negative 2 times each of these, just like we did on number 5. So plus, whoops, it will be a minus sign. So negative 2 times c squared is negative 2c squared. And a negative 2 times a negative 4. Oh my gosh, I am going to rewrite that 2 there. Okay, so you get plus 8, and you get c, because the 2 does not have a c. Negative 2 times 4 is negative 8. All right, let's bring it all together. Oh, excuse me. So if I add it all together, I'm going to have c to the third power. I'm going to have minus 6c squared, because this c squared adds with this c squared. They're both negatives. 4c and 8c will add together and get 12c. And then my last one, minus 8, doesn't get to add with anything. Is it a lot of steps? Yes. Is there a lot of ways you can go wrong? Absolutely. Please go back, pause, rewind, fast forward. I hope this didn't take too long. If you have questions, please reach out to me, email me with your questions. I will be back Friday morning if you want to come in at 8 o'clock, and I will help you then. Otherwise, I'll help you in class next week when I see you. All right, y'all be good for the sub.